Okay, so yesterday we talked about and compound inequalities, and today we'll talk about ORs. So I'm going to call this, I forget what section we're in, 12. Well, 5. So this would be 12.5 continued with ORs. Okay, so yesterday with the ands, both things had to be true. So I had a lot of problems yesterday, for example, that were like a number greater than 3 and less than 9 at the same time. For ORs, I don't have to satisfy both of them. Only one thing has to be true. So for example, with ands, we said a number greater than 3 and less than 9. For ORs, only one must be true. So for example, I might say, give me a number less than 5 or greater than 8. So there is no one single number that would fit both of these, right? That doesn't exist. There are no numbers that are less than 5 and greater than 8. But if I'm saying, hey, listen, just give me any number that's either less than 5 or greater than 8, you could give me lots of examples that work. So give me one number that does fit this. Give me a number that's less than 5 or greater than 8.
6.
Sure. No, wait. Not 6. I need a number that's either less than 5 or greater than 8.
9.
Sure, 9 would be an okay answer. Give me another one. Natalie? 3 would be another good one. Give me another one. Would 0 be okay? Yeah, because it is less than 5. How about would, I don't know, 1,000? Would that be okay? Sure, because that's a number greater than 8. So we have lots and lots and lots of examples of things that would work. Let's just do a couple that would not. So I said no to 6, right? Because 6 doesn't fit either of these. 6 is not less than 5 and it's not greater than 8. So 6 would not work. Give me another one that would not work. Right. 7 would not work. What if, you're right. 8 also would not work because I said greater than 8. And 8 is not greater than 8, it's equal to it. You could even do decimals, right? You could do like 6.5. That doesn't work either. So there's lots. There's an infinite number of numbers in both of these. But I just wanted you to kind of have an idea where these are. All right, yeah, go so fast. So we are going to try solving some of these OR problems, which are actually, in my opinion, a little bit easier than the ANDs, because they're always going to be two separate. They are never written as like that and sandwich that we had yesterday, where it's just like one big problem. They're always two separates, and they always use the word OR. So I literally just solve each one separately and then graph them both. That's it. So the first thing I'm going to do is solve each separately. That's an A. It's supposed to be an A. I don't know if that's an E or an A, but you know the word that I'm trying to spell. Solve each separately, and then you just graph both. That's pretty much as hard as these get. So let's try a few and see what we're talking about. So I'm just going to make one up. Oh, sorry, I already messed up. Well, so first I have to solve each one. So for this, it's just like having two little mini problems in the same one. Yeah, so for that first one, we're gonna -3 from both sides, easy peasy. So I just get X is less than 2. I need to use that word or though. You gotta keep that word or in your answer. And then over here, for the 2X is greater than 10, what should I do? Right by 2. I don't want to I'm not going to minus because I wasn't adding, but I was multiplying, so I'm going to want to divide. So this is my answer. Okay, so notice I have the word or, and that's important. You don't want to leave, if you leave that out, then I don't know if it's an and or an or problem. So you got to have the word or. So I want a number that is less than 2 or that is greater than 5. So could you give me an example of a number that is less than 2 or greater than 5? Sure, 1 would be fine. Give me another one. 10. I was thinking 10 also. 10, that would work also. But a number like 4 would not work here, right? Because it doesn't fit either one. I don't need them both to be true, but I need someone to be true. So let's talk about graphing these. I'm pretty much just going to graph them like I normally would. So I have a 2, I have a 5. What kind of a dot should I put at the 2? Open. Now listen though, if I was just graphing X is less than 2, which way would I be shading? To the left or to the right? To the left. So there's that graph. And then I'm just going to graph the other one. That was it? Yeah, this one's going to go to the right. I want an open dot. I want the X is greater than 5. They go this way. So remember how yesterday we said that almost all the time the ands just make a bar? The ors almost always just go in opposite directions of each other. Almost always. There are a couple of exceptions. I'll show you that in a minute. But let's practice a few more of the typical ones that you're going to see 99% of the time. Okay, so let me give you another one. Do the same thing. Solve it and then go ahead and graph it. All right, let's see if I can squeeze one more example here. Let's do something like x divided by 3 is less than maybe 1, or x minus 6 is greater than . All right, try that one. So solve each one separately and then go ahead and graph. Yep. Okay, so what do I have to do for this first one? I'm gonna times both sides by 3, right? Because I'm dividing by 3, I want to do the opposite. So I'm gonna times by 3 over here and over here. When I do that, those 3's cancel. 1 times 3 is just 3. You are right. What are you doing first though? Yeah, I'm gonna add that 6 to both sides, right? So that's gonna get me that x is greater than 16. All right, so now on my number line, just like you said. Yeah. Perfect.
Rock star. Was that 1 week you spent in my class? Not too shabby.
So give me an example of a number that would work as a solution here. I shouldn't hear that. No, not 4. 4 is not, I need a number that's less than 3 or greater than 16. 4 doesn't fit that, right? But give me a number that does fit that. 20, sure. Remember, when you are shading, the whole point of these arrows is you're saying, hey, all of these numbers are my solutions. Every single number that's bigger than 16 is going to be an answer. Every single number that's less than 3 is going to be an answer. Right? So these ones in the middle that are not shaded over, those are the ones that do not work. So everything in between 3 and 16, no good. All right, I'm going to step it up a notch. Let's try ones that are a little bit tougher. And then I'll show you some of those weird cases. Okay, so I'm actually going to steal one from the worksheet you're going to do in a minute. So that'll be one less you'll have to do. This one has 11 minus 2x is less than -7, or -11 minus 10x is greater than or equal to 89. All right, everybody try this one. Again, you're just going to go one at a time. just solve each one separately. Yep. Yep. That'll be true for any time you're dealing with inequalities. Okay, ready to try this one? So we're just gonna do one at a time, right? So if I look at this one here, what should my very first step be? Yeah. Well, this one here, 11 minus 2x is less than -7. That's gonna be my second step.
So you add 7 and subtract.
I gotta get rid of this 11 first. Remember, I'm trying to get the x by itself. So I have to get rid of the 11 and the -2. So we always kind of work whatever is furthest away first. If there's any addition or subtraction to do, I do that first, and then I'll do division or multiplication. So first step, I'm gonna subtract 11 from both sides. So that's gonna get me a -2x is less than -18. What would I do now? Exactly. I'm going to divide both sides by a -2. And when I do that, what happens? I got to flip that sign right over because I just divided by a negative number on both sides. So that one's done. Okay, great. Now I got to come over here and I basically do the same thing over here. I'm just going to start with my very first step on this one. Add the 11, right? Because this time that 11 is negative. So I'm going to add it to both sides. And that gets me, what's that, 100? And now I can divide both sides by -10. And again, I'm dividing by a negative, so that symbol's got to flip. Make sure you bring down the word or. So did everybody get this part right? I want x is greater than 9 or x is less than or equal to -10. You got those two numbers? Okay. Now on my number line, please make sure that you put, it's always your smaller number goes over here, right? That way it's getting smaller, this way it's getting bigger. So who's smaller, 9 or -10? -10, so -10 goes over here, +9 goes over here. What kind of a dot should be at the -10? Closed. And I want to shade to the left. I want all the numbers less than -10. They're all that way. And then for 9, open circle, right? Because I don't have that bar underneath. I want all the numbers greater than 9 should shade that way. That should be your number line. Right? Making sure you have the -10 on this side and the +9 over there. Sometimes that's a common mistake that kids put them on the number line the wrong way. And then that messes everything up. So number lines always, always, always smallest on the left, bigger on the right. And then you just grab.
So they don't always go.
They can. So those are the weird cases. So right now I want to show you just a couple of the weird cases. Almost all the time, the ORs go opposite directions of each other. Almost always, the ands just go towards each other and make that bar. But every now and again, you get one that doesn't follow that pattern. So I do at least want you to see it, even though it's rare, but it does happen. So I want you to know when you see it, how do you actually answer those? Okay, so I'm going to title that these are weird cases. So let's say you're doing your work, you get to an answer, and the answer says X is greater than 3 or X is greater than 5. So this is weird. If I graph them both on the same on the same number line, right? I have 3, I have 5. Watch what happens with these. I'll try and do them in different colors. So if I'm going to graph X is greater than 3, that should be an open dot at 3. And then which way do I shade though for X is greater than 3? I shade to the right. So there's that one. Now let's graph the other one. X is greater than 5. So I'd have I'm actually going to write them. I'm going to actually put them right on top of each other. I want X is greater than 5. So that would also go to the right. That's weird, right? They both go this way. So here's the thing. If I say to you, hey, someone shout out a number that's greater than 3 or greater than 5. Couldn't I have just said, shout me out a number that's greater than 3? Because isn't a number that's greater than 5 automatically greater than 3? Right? They overlap each other. So I don't even need to say the greater than 5 part. I just need one of these two things to be true. So here's my easiest way to explain this. If you have an OR, just literally graph them both on the same and just let them overlap each other. So your final answer, if I just clean that up a little bit, it's going to look like this. I still have an open dot at 3, and then it just goes on forever. I basically just smoosh the two graphs together. I'm sorry. Now, what about this? There was an open circle at 5, right? But if I say, hey, give me a number that's greater than 3, 5 does work. So it doesn't matter that it was open before because I kind of am ignoring this whole one altogether anyway. All right, so bless you. For an OR, just graph both, and I'm gonna say smoosh together. So I'd literally just write them on top of each other and then just graph the one that's there. Let's try one more. Let's do one that's going the other way. How about x is less than 4 or x is less than 2? Let's make these or equal to, just so we have some variation. Okay, so go ahead and you try that. Graph me x is less than 4 or x is less than 2. Now you're gonna have a 2 and a 4. These are your answers. So you're just gonna graph them as they are. Yeah. So what's that final graph gonna look like? Basically, right? It's just the two smooshed together. So if I just graph this once, like as one final graph, go super fast. So it's going to start at the 4 and go forever to the left. That encompasses both of these things. I just smoosh them together and it just becomes this one graph. I kind of wish I had Play-Doh, and then you could, like, remember making the snakes out of Play-Doh, right? So you could have, I want you to imagine, I have one line of Play-Doh and then I have another line of Play-Doh and I literally just roll them into one giant snake. That's what I'm doing with the ORs. But there are weird cases for ands too, where it's a little bit different. But are we okay with this before I talk about that, the and weird cases? All right, real quick, we don't have much left to do. So let's say you wanted to graph x is greater than 3 and x is greater than 6. So this is an and. So if I start off graphing them like normal, I would have x is greater than 3. Then I'll do this one in orange. X is greater than 6. For an and, I don't want to just draw them basically on top of each other. What I want is only the pieces that overlap each other. That's what's going to be in my final graph. So in my final graph, if I need it to be greater than 6 and greater than 3, it's going to look only like this. I only take the part where they overlap each other. Because I need it to work for both, right? So if I were doing my Play-Doh snakes again, right, and I had a purple snake and an orange snake, and then I did roll them together, I'd only want the part where the purple and the yellow, or purple and the orange mix. That's the piece that I'm keeping. That has to work for both of them. Maybe if I remember tomorrow, I'll bring Play-Doh in. But the problem with Play-Doh is that once you mix them, then it's mixed. I don't know. Someone should invent a Play-Doh that can like separate back out to its original colors. That'd be cool. Have you guys used that kinetic sand? That stuff is so cool. Do you know what I'm talking about? The kinetic sand? I could play with that stuff all day. It's so nice. Anyway. All right, so those are the weird cases. Again, the weird ones don't come up very often, but I just wanted you to see it in case you do ever come across it. So let me go ahead and give you some of the ORs that I want you to practice today. Just mark this off. Oh. Any questions right now? You guys are so quiet today. All right, so let me give you this. We'll go from there.